So here's a new style of question, and this is a sort of tracing question, but it's meant mostly for comprehension. So it isn't intended to be the full diagram style tracing because, in fact, you aren't actually given all of the code. So I've condensed this from the version that's in the actual practice exam, so take a look at that. But you're given some code that contains definitions for linked list structures, so the linked list object and definition for the structure that represent a node, and you are given these function signatures, and in the online version it actually has documentation for them. You're given these function signatures for functions that you are told exist and work, but you're not actually given the code for them. So what I mean by that is this function called reverse takes a list, and just to give an example, so suppose we have this list here. You aren't given the code for the function reverse, but you are told that the function reverse works as expected. And what is it supposed to do? It takes all the elements in the list and puts them in reverse order. So if you pass in a list that has elements in one order, when you're done, the list will have all the same elements, but in the exact opposite order. That's what the reverse function does. And the key thing is you are just given the signature. You're told how to use it, but you're not actually given the code. And the reason is actually because we're just going to use this as a tool in a tracing exercise to understand how lists work. The same is true of add front and print list. So let me see here. The add front function, as we've seen, we actually have seen the code for this in previous examples. The add front function takes a list and an element and then adds that new element at the beginning of the list, and then print list obviously outputs all of the elements of the list. So given that, here is some code. Figure out what is in the list as of this line. And you're allowed to assume that the reverse function, the print list function, and the add front function works exactly as expected, but you're not actually allowed to see the code for them. And the goal here is to boil this down to hopefully a relatively manageable tracing exercise involving what really is going on here. So we could do this with a full diagram, but it's a little bit of a waste because we don't need things like scoping in the context of this to be able to understand how this question works. So I'm going to try walking through main. I'll show off sort of the diagramming style I would probably use for this question. So I start inside of main. I have this linked list called L, and it is worth making note that this is my linked list object. Whoops, not a pointer. But inside of it, it just contains my head pointer. I don't even bother giving it a type in the usual sense because I'm not going to worry so much about that because we're talking about code that we know is correct. We're told that it's syntactically correct and that works with these functions that we don't actually have code for. Okay, so when main begins, as of this point here, my list is empty. The head pointer is null. And then I add, at the beginning of the list, I add the value 225. Now, I already know the way this is going to go, so I'm actually going to write it all the way over here. So after that first call to add front, after this, my list looks like this. Because I'm going to call add front, I've left a bunch of space here because I sort of know what's going to happen next. Then I add at the front of the list the value 187. Okay, so I make a new node at the beginning of the list. We assume the add front function works correctly, and it contains the value 187. And then I add at the front of the list the values 17, then 10, then 6. Okay, so there's 17. And then there's 10. And then there's 6. All right. And so then on line 18, I call this function twist. And I hand it my list, so it goes in as L, and I'm actually not going to bother with scoping boxes for this. I've mentioned earlier in the course that there comes a point when we're talking at a high enough level when the scoping boxes don't actually help us. This is a question that isn't designed to be full of scoping shenanigans. We might notice there's no if statements, no loops, no weird duplicate declarations of variables, so let's instead talk about it conceptually. The function twist gets my linked list L. Okay, there it is. It has my linked list. I don't need a scoping box to keep track of that. And then it creates 3 pointers. And as usual, I'm going to draw the pointer with this symbol here to differentiate it from these boxes that I'm using to refer to nodes. So it creates 3 pointers, node 1, node 2, and node 3. Okay, there they are. And then node 1 will be L, follow it to the head, follow it to the next. Okay, so let's see. L, head, arrow, next. Okay, so then I end up here. So node 1 will point to this. Node 2 would be node 1, arrow next, arrow next. Okay, so node 1, arrow next would be the 187. And then finally, node 3 is node 2, arrow next. Okay, so I have these 3 pointers, and now I begin making modifications. So node 3 arrow next equals node 1 arrow next. Okay, wait, what's node 1 arrow next? Okay, that would be, there's node 1 arrow next, so that's this. Okay, node 3 arrow next will now be a pointer to this. So there's node 3. The next pointer of node 3 now points to here. All right. So that's this statement taken care of. Node 1 arrow next equals node 2 arrow next. What's node 2 arrow next? Okay, there's node 2 arrow next would be this. Okay, so node 1 arrow next equals, is going to point at the 225. So node 1 arrow next would be this thing. So it now points up here. All right, that's this statement taken care of. And then finally, node 2 arrow next is going to end up equaling null. So there's node 2, it arrow next would be this thing here, and that's going to equal null. I've done that, and that means I'm done the twist function. And for the sake of cleaning things up, that means I should probably erase this stuff so that I can try and reconstitute my list. So if I tried to print the list out now, what I would get was 6, 10, 225, 17, 187. And I think I'm actually going to write that in, because I know that this is a tangled mess and I might not be able to understand it. So I'm actually going to redraw my list to be in order. 225, 17, and then 187. There it is, and we'll just clear this out. So we'll have the head of the list now is just down here, and we'll just get rid of all this stuff. All right, so I've now finished my call to the twist function, and I'm back on line 19, reverse. And we haven't been given the code to the reverse function. We've just been told that it works. Okay, so if it works, I guess it should do the following. The list should end up being 187, 17, 225, 10, 6. Okay, so once I've finished with the reverse function, this should be the contents of my list. And then, after that, on line 20, I call the twist function again. So I go back into my twist function, I make my 3 pointers again. There's node 1, and there's node 2, and there's node 3. All right, and I set node 1 to be L, there's the head, and then that arrow next. So that would be 17. I set node 2 to be node 1, arrow next, that would be the 10. And then I set node 3 to be node 2, arrow next, which is the 6. All right, then I do the same 3 assignments I did before. Node 3 arrow next equals node 1 arrow next. Okay, wait, what's node 1 arrow next? Node 1 arrow next would be this thing. Okay, so node 3 arrow next, that's this pointer, now points to that. There it is. And then that's that assignment taken care of. Node 1 arrow next equals node 2 arrow next. Okay, what's node 2? There it is. Node 2 arrow next would therefore be this thing. Node 1 arrow next will now point at the node with the 6. So I'll write that down there. And then that's that pointer taken care of. And then node 2 arrow next equals null. So here's node 2. Here's its next pointer. That now equals null. And the twist function's over again. So I will erase node 1, node 2, node 3, and then take stock of what I have. I could redraw the list, but the question is, as of the call to print list, in other words, the next line of main, tell me what's in the list. And if you'll notice, the way that it asks on Connix is you have to enter the elements of the list into boxes. So I may actually not need to rewrite the list to figure that out. So what are the elements of the list? There are 5 of them. Okay, so well, let's see. The first one is 187, then 17, then 6, and then 225, and then 10. And so that's it. And maybe you can agree that although, yes, there were functions I was calling, and yes, there were variables, I don't need scoping boxes for this because it's really more of a comprehension exercise about linked lists. And just like we've seen in previous examples, it's okay to throw away parts of your diagram as you need if it makes your life easier. The important thing is to know when to make that decision. And I'll just declare in advance, if you get a question like this on the final exam, and it wouldn't surprise me if you do, then maybe it's better just to think about the list and how to manipulate it and not think so much about scoping diagrams. You could still do that. It would still work. It would just take a bit of extra time.